Good morning, class. This is your lecture 9. Lecture 9. Today we will solve some problem from NCERT and our worksheet related to the refraction of light. Okay. So, first question is question number 19 from our worksheet. So, the question number 19 second part is actually first part I am not going to solve because it is quite easy. Second part is a sphere of diameter 20 cm is placed in front of a convex lens of focal length 5 cm. What will be the area of its image? Find the position, nature and ratio of the area of the image to the object. Okay. Now it is not given where is the position of the object. So in group I have sent that the position is 3 times as the focal length. Okay. So solution. So position of object is equals to 3 times its focal length. Okay. So position of object is 3 times its focal length. Now the lens is convex lens. So focal length is positive. F is positive. Okay. So position of object is denoted by U. So U will be 3 times. What is the focal length? Focal length is 5 cm. So 3 times plus 5 is equals to 15 cm. Okay. Now U is 15 cm. F is equals to plus 5 cm and U is always negative. So whenever we solve the question, we take U as a negative. So U is negative 15 cm. Why it is negative? Due to sign convention. From sign convention. Okay. Focal length is plus 5 cm. So first we have to calculate V. Where will be our image? What is find the position of the image? Okay. So how can we find the position of object? From lens formula we know that 1 upon F is equals to 1 upon V minus 1 upon U. This is the formula. This is lens formula. Clear? Now put the value of these in this formula. 1 upon 5 is equals to 1 upon V. We have to calculate minus 1 upon U is minus 15. So this is minus 15. So 1 upon 5 is equals to 1 upon V minus plus 1 upon 15. So transpose 1 upon 15 to this side. So this is 1 upon 5 minus 1 upon 15 is equals to 1 upon V. Okay. So take the LCM. 1 upon V is equals to LCM is 15. This is 3 minus 1. 1 upon V is equals to 2 upon 15 and V is equals to 15 by 2 and this is 7.5 centimeter. Okay. So position of image is 7.5 centimeter. It is positive, so towards the right side from the lens. Okay. Now we have to calculate nature. So nature, how can we calculate the nature of this image? So let us bring me another page. So we know that U is negative 15 centimeter. V is equals to plus 7.5 centimeter. Okay. So to find the nature of the image, we have to calculate its magnification. So sign of magnification will give me the nature. If it is positive, then virtual and erect. If it is negative, then real and inverted. So we know that magnification M is equals to V upon U. This is the formula for magnification. This is for magnification. magnification. Okay, now magnification is equals to V upon U. So M is equals to V is here positive 7.5 centimeter divided by U is minus 15 centimeter. Okay, so magnification is equals to this 7.5 can be written 15 by 2 and divided by this 15, and sign is negative, so 15 to 15 cancel. M is equals to minus 1 by 2 and this M is equals to minus 0.5. So our magnification is 0.5, or we can say magnification is half, means the size of the image will be half the size of the object. So size of the image, so this is size of the image is half the size of the object. Clear? So magnification is negative, so nature is real and inverted. Clear? So nature is real and inverted. Clear? Now we want to also calculate the ratio of the area, of the image to the object. So first we have to calculate the area of the image, then we have to calculate the area of object. Okay, so a sphere of diameter 20 centimeter. So diameter is 20 centimeter, means its ray diagram will be, suppose this is our convex lens, this is principal axis, and above the principal axis we have put a sphere. Now, and this is 15 centimeter. Okay, and where is the image? Image is 7.5 centimeter, right? So this is real and inverted, so inverted means down the principal axis. This is our screen. So we can see the screen is always two-dimensional, 2D figure. Screen is always 2D figure. So its image will always form in a two-dimensional figure. So if this is a sphere, this image should be a circle. Okay, its image should be a circle because we are obtaining the image in two-dimensional plane. Okay, so image will be a circle. Clear? Now we have to take this sphere as a circle also, because for this screen it will get that it is also a circle. So means we have to get the ratio of two circles having diameter d1 is equals to 20 centimeter and d2 we don't know. So to calculate d2 we have to calculate the height of this object. So height of this object will be the diameter of the image. So how we can calculate d2? We know that m is equals to h prime by h. H prime is the diameter of the object, image, and h is the diameter of object. So magnification is minus 1 upon 2 and this is h prime we have to calculate, and h is 20. So from here h prime is equals to minus 10 centimeter. Okay, so diameter negative sign showing that it is below the principal axis. So we have to calculate this is the diameter. Okay, so this is d2. So d2 is equals to 10 centimeter. Okay, now we know the d1 and we know d2. So the half of d1 will be radius r1 is equals to d1 by 2. So this will be 10 centimeter. R2 is equals to d2 by 2. So this is 5 centimeter. Now this is 10 by 20 by 2 is equals to 10, and d2 is 10. 10 by 2 is equals to 5 centimeter. So we can area of the image, area of the image is equals to pi r1 square, and area of the object, sorry, pi r2 square, area of the object is equals to pi r1 square. So how can we calculate the ratio? Okay, now the ratio, required ratio, we can say this is pi r2 square by pi r1 square. So pi is cancelled, so r2 is 5, this is square, divided by r1 is 10, so this is square. So this is 25 divided by 100, so this is 1 by 4. So required ratio is equals to 1:4. So this is your answer. Okay, now the next question from NCERT, this is question number 9. It is given 1/2 of a convex lens is covered with a black paper. Will this lens produce a complete image of the object? Verify your answer experimentally. Explain your observations. Okay, so suppose we have a convex lens and half of its portion is covered with a black paper. So no light will pass through this paper. So will image will form? So let us check. Suppose we have a convex lens. So we have a convex lens. This is the convex lens. This is principal axis, and half of this convex lens is covered with black paper. Okay, so this is covered with black paper, means no light can pass through this. Clear? So will image, suppose this is an object placed at some distance from the lens. So what do you think, that should its image be formed or not? So to form an image, we already know that we have to pass two rays. Earlier one ray goes to the parallel to the principal axis, and after refraction it passes through focus. Let this is F. Okay, and second, earlier we passed the light through optical center, but it is I have already told that it is not necessary to pass the light from the optical center only. We can pass light from anywhere. Okay, so we can pass a light from this portion also. So it, from laws of refraction, suppose this is normal or this is angle of incidence. So what will be the angle of refraction? This we can calculate by, if the refractive index of this material is given and we know at what angle our light is incident. Okay, so this we can do experimentally, but for as a theoretical part, we can also apply the Snell's law, and we will find that at a certain angle it will diverge like this. Okay, so it will go like this. So here it is meeting. So this, if this is A and this is B, so the point where it is meeting, it should be the A prime. Okay, this is our principal axis, and perpendicular to this will be our image. So either our half portion of the lens is covered, our image will be formed. So image will be formed. Okay, similarly you can pass another line, and from this angle of incidence is changed, so angle of refraction must be changed. So again this will pass through the same point. Okay, so this is your answer. You can verify your answer experimentally whenever we will go in lab. So we can find that if one portion of the lens is covered, still the image will be formed. Okay, so this is your answer. Now the question number 11 or question number 10 from NCERT is quite easy, because everything is given to us. We have to calculate sometime f, sometimes we have to calculate u, sometimes we have to calculate v. So this is quite easy. 10, 11 and 12 is easy. 13 question, the magnification produced by a plane mirror. So question number 13 is magnification produced by a plane mirror is positive 1. So for magnification is +1, it is only for plane mirror. You have to keep in mind plane mirror. What does it mean? We already know plus sign means it is virtual and erect. And once means same, it means same size. So magnification produced by plane mirror is +1 means image is virtual and erect and of same size. So as you can see, you often see that whenever you stand in front of a plane mirror, okay, so the image of you is same as the object, okay, same as you. Clear? Similarly, the question number 16 is the focal length of the lens of power. Find the focal length of the lens of power. Power is -2 diopter. Okay, what type of lens is it? So minus means it is concave lens. It is concave lens. So this is concave lens, and we know that power is equals to 1 upon f in meter. So focal length is equals to 1 upon p. So focal length will be -1 upon 2. So this is 0.5 meter minus. So this is easy. Again, next question is question number 17. A doctor has prescribed a corrective lens of power. So question number 17. This is power is equals to +1.5 diopter. We know that if power is +1.5 diopter, it means lens is convex lens because its power is positive. We can find the focal length. Focal length is equals to 1 upon p from here. Okay, so putting the value of this power, we can calculate its focal length. Okay, and is the prescribed lens diverging or converging? We know that this is convex lens because its power is positive. So convex lens is always converging lens. Okay. Here, so we have another question. Why should we have to be careful while entering in the swimming pool? Okay, so sometime we go to swimming pool. So why should we have to careful while entering the swimming pool? So it is because the depth of the swimming pool as it appears is way greater than it is. Okay, so whenever we go to the swimming pool, suppose this is our swimming pool. Okay, this is our swimming pool, and this is the bottom, and this is the suppose water level. Okay, water level. So the image of the depth, this is the depth. Let this height is h, we can say h, where h is the real depth. So to form the image of this surface or this point, we have two rays, one like this, and at the point of this is interface. At this point we can draw normal, and since this is water, what is denser and this is rarer, so light will bend away from the normal. So it should go like this, but it will bend away from the normal. Okay, so this is the case. Now second light ray will go like this. Again, this is normal, and this will also go away from the normal. Oh sorry, direction is this. Okay, now these two rays are diverging. So we can see if we produce these light ray in opposite direction, it seems that this is meeting at this point. So the image of this point is this. Similarly, we can draw infinite points, and the image of these points will be always formed here. Okay, so let this, from above we are watching the swimming pool, so the image of this surface is formed here, and we will find that, oh, the image of this swimming pool, the depth of this swimming pool is this much, h prime. Okay, so h prime is apparent depth. Okay, so why should we have to be careful while entering the swimming pool? Because the apparent depth is less than the real depth. Okay, so the depth we are watching is actually less than the actual depth. Okay, so means the depth we are watching is very much less than the real depth is way larger. So if you are going to swimming pool, you will find that, oh, this is the very less depth of this swimming pool, but actually the depth is very large. Okay, so we have to be careful while entering the swimming pool because the depth is appeared less. Okay, so from here we can calculate, if we know the real depth of this swimming pool or apparent depth or whatever, so let this is the refractive index of this swimming pool. So the formula is real depth upon the apparent depth is equals to the refractive index. Okay, so real depth upon apparent depth will be is equals to refractive index. So this is how we can, so this is, there is no numericals related to this in your NCERT, or this concept is not given in your NCERT, this formula, but still you can find the real depth and apparent depth. Okay, so this is a really very important question. Why should we have to careful while entering the swimming pool? Okay, the theory part you have to write by yourself. Now all the questions related to refraction given in the worksheet or NCERT we have solved. Okay, so if you have any problem related to refraction, or if you have any problem in any question, okay, so you can ask me in the comment section or in WhatsApp. Okay, so make sure that all the questions given in the worksheet or NCERT related to the refraction of light must be solved in your classwork notebook. I will check. Okay, so all the question you have to do in your classwork. So in next lecture I will start our new chapter, Human Eye and Colorful World. Okay, so up to this you have to write all the notes, all the questions in your classwork notebook. Okay, thank you class.